Stanford University.
Okay, well, welcome to Lecture 4 of Stanford CS193P, spring of 2016. Today, our topic is views. Okay, views are the rectangular areas on screen that we draw in. It's also the places where we handle multi-touch. We'll be talking about that next week. So today, it's all about the drawing side, and I, of course, have a demo where we're going to draw a custom view. Okay? So let's talk about views. A view is that rectangular area, as I said. It defines a coordinate space, okay? So anytime you're drawing or handling input or whatever, you need a coordinate space to be defined for you, and use that space to draw and to handle touch events. This kind of view setup is hierarchical, as you might imagine. So you can imagine that you have some view, like maybe this is the view that contains your entire UI for an MVC. And then you've got some subviews, maybe they're buttons or whatever, and they might be inside a view, like let's say a stack view or something like that, and maybe those are in another view, okay? So you can see how these things are hierarchical, right? You're building your views in a hierarchy, a view hierarchy we call it, okay? Now, these views can overlap, obviously, and they also, even if you have a view inside a view, so a view, let's say in this view right here, if you had another view inside it, it could actually extend outside the bounds of its parent. That's legal. And you can set a switch in the view whether it's going to clip and only show this part, or whether it'll allow this thing to draw outside of its parent. Okay? So that's how we build our user interface, is by kind of grouping these things together. You're totally familiar with that in the calculator. And when you build something like this, every view ends up having a single super view, right? That's the view that it's inside. And any given view could have any number of subviews. Okay? Like the stack views could have any number of things stacked inside of them, whatever. The subviews, you can find them for a view by looking at this var, this UIView var called subviews. You see it's an array of UIView there. And we'll talk a little bit later. The order of those subviews matters. And that's it, basically. Okay? That's how we represent this view hierarchy. There is a UI window in iOS, but it almost doesn't matter. Okay? You're never going to interact with it. There's always only one per app. Actually, you could have more than one if you had like an external screen, okay? Like you were doing, what do we call it? The screencast, it's not coming to me, where you can have a second screen. I can't think of it, but like on Apple TV, you could have a second screen for your device, whatever. So then you might have two UI windows, but it wouldn't matter because you're almost never going to create one or send a message to one or whatever. So it's all about views. It's all about this view hierarchy that we're going to build, okay, in iOS. It's unlike on the Mac, where of course on the Mac you've got windows, right, separate windows. You don't really have that in iOS. Not enough room really to do that. This hierarchy is most often constructed in Xcode graphically, like you did with the calculator, okay? But you can build this hierarchy in code. The two methods are add subview and remove from superview. That's putting them in and taking them out. Notice that add subview is sent to the future superview of the view, saying, here, add this subview to yourself. Remove from subview is actually sent to the view you want to remove. Okay, so remove from subview, from superview rather, is kind of like remove yourself from your superview. Okay? Where does the view hierarchy start? Okay, it starts right at the top, okay, in that MVC that we see in the storyboard. There's a view that fills that whole space. There is a pointer from your view controller to that top level view, okay? That pointer is called view, okay? So if you look at view controller, right, everyone knows what view controller is. That's where you put a lot of your code in the calculator, right? Where you wired up all your outlets and actions. That class, view controller, has a var called view. You haven't used it yet, but it is a pointer to the top level UI view. Okay, and that's an important view to have a pointer to because you're going to be adding subviews to it, et cetera, especially if you're doing it programmatically. You really need this var so you can call add subview on it and put some things in there. And this view is automatically hooked up for you in your storyboard. So you don't have to do anything. It's just automatically hooked up. Okay, and this top level view is the view whose bounds will change, for example, when you rotate your device. Right? The bounds go from being tall and thin to being short and wide, okay? That's the bounds of this top-level view. Now, when you change the bounds of this top-level view, if you have constraints like we put in the calculator where we tied the stack view to the edges, when those edges change, of course, the stack view gets pulled around and stretched. And the stack view knows how to resize and distribute the things inside of it. That's part of what the stack view does. That's pretty much all it does, actually. So that's why rotating, changing the bounds of this top view causes a ripple effect where everything repositions inside, okay? Now, let's talk a little bit about initializing a UI view, okay? As always, we want to try to avoid doing an initializer if we can just get away with saying equals whatever. But if you have to have an initializer because you just feel like you just can't initialize a var somehow else, then you have to be careful with UIView because it actually has two important initializers, okay? One of them is required. That's the second one, init with coder. That init is the init that's used to create the UI view when it's coming out of a storyboard. Okay? So if you built this view by dragging it out into your storyboard, when the storyboard gets reconstituted at runtime, then this is the init that's going to get called, init with coder. The init with frame, that's the init that you're going to call if you create a view in code. Okay? And that frame that you're specifying is the frame of this view in its super view. In other words, where it's going to be, where this view is going to be. And it is legal to just do init with no arguments. That's going to essentially be 0 rect. It's going to put it like up here in the left-hand corner, really, really small. You could set its frame later then to move it. Anyway, since you have two of these things, and one of them is required, the second one, you're going to end up implementing both, okay? Because you're going to want your views to be able to work from storyboards, or you want people to be able to instantiate them from code. Okay? So I recommend putting all your initialization code in something like a setup function here, and then override both of these two and call setup from both of them. That way they'll both be doing exactly the same setup, right? Makes sense, kind of obvious. But I just want to make sure you know you got to do both of these. All right, another initialization mechanism that you can do for UIView, but only works for views coming out of storyboards, is to put your code in this method awake from nib. Okay, awake from nib is actually called on any object that comes out of a storyboard, okay, but not called at all if you create an object in code. And so you can, put same kind of setup stuff that you would put in the other one, as long as you're fine with your view only working when it's coming from a storyboard. Okay? All right, so now let's talk about the drawing. Okay, I've got this UI view, and I want to draw. Well, before I can show you how to draw, draw something inside of these, your custom view, I need to talk about some types, some data types. Okay, the first one here is CG float. So we don't use doubles or floats. I haven't really talked about the float struct in Swift, but it's just like double. It's just that float is single precision and double is double precision. That's why it's called a double. But we don't use floats or doubles when we're drawing. We use this special struct called CG float, okay? And that means that sometimes you're going to be doing calculations in doubles, and then you're going to want to draw with the result. You're going to have to convert it to a CG float. By doing CG float, call its initializer. There's an initializer for CG float that takes a double, luckily, and another one takes a float, okay? So always using CG floats. And you'll run into some trouble here and there because you're trying to pass doubles into API that takes CG floats because it's drawing API, okay? There's a couple other obvious structs. There's a CG point that just has two vars in it. One is the X and one is the Y, right? That represents a point. And then a CG size, same thing, a struct with two things, a width and a height. Okay, those are easy. Then there's CG rect. CG rect gets its own slide because even though it's obvious, it has an origin, which is a CG point, and a size, which is a size, right? It's a rectangle, has an origin and a size. It also has a lot of methods on it, okay? Cool methods you can use, or vars and methods like finding the minimum X value of this rectangle, or the mid Y point of this thing, or even intersect this with another rectangle and give me the intersecting part, like this slashed area here, okay? Or this one intersects, which says, does this rect intersect this other rect, right? You can imagine there are a couple dozen of these kind of utility methods. So you want to definitely get to know them so you don't end up writing these methods yourself when you want to intersect two rects or whatever. Okay? So those are the main types that we're going to use when we draw. So you're going to be familiar with those types. All right, let's talk about the coordinate system we're going to draw in our view. Okay, the origin is in the upper left. Okay, it's not lower left like Cartesian coordinates or like the Mac. Okay, when you draw on the Mac, if you're building a Mac app, it's in the upper left. So that means increasing y means you're moving down the screen. Okay, so if you look at this point I created up here, 535, notice it's 500 over in x, but only 35 down in y. That's why it's way over on that side there. Okay, the points that we're talking about here in drawing when I mention all this are, or the units, if you want to think of it, are called points. Okay, now a point is not a pixel. Some iOS devices are extremely high resolution, like the iPhone 6 Plus, very, very high resolution. It has 3 pixels per point. Okay? Some of the other devices have 2 pixels per point, and some have 1. Now, you're always drawing in points. Usually you don't care too much about the pixels. If you have a lot of pixels, it just means the lines that you draw are going to look really smooth, or the images that you have are going to be really detailed. You're going to be able to use a lot of image data to draw them. Okay? But if you do care, and actually in assignment 3, you are going to care, so pay attention. If you do care, you can find out by asking a UIView, what is your content scale factor? That's basically how many pixels per point. Okay? The boundaries where you draw in. So this is super important, and this is where a lot of confusion comes in. This is why I spend a lot of time in this, even though it's very simple, but people just get these things messed up. Let's talk about the rectangle in which you draw, okay? Because you're going to draw inside a rectangle. When you are drawing, you're using this var in your UIView. It's called bounds. It's a CG rect. That is the rectangle in which you're drawing in your own coordinate system, in the coordinate system you're drawing in, okay? So anytime you're writing drawing code, you're using this, okay? There's another thing called frame, which is also a CG rect, which people confuse between these two. But frame is completely different. It has a completely different purpose, and it's in a completely different coordinate system. Okay, so if you try to use frame instead of bounds, it might work in certain circumstances, but then be messed up in others. So what's frame about? Frame is about where your view is in its super view. Frame is a rectangle, a CG rect, that completely encloses you in your super view's coordinate system. Okay, so when I want to put some view somewhere, I have to specify where in its super view it goes. I do that by specifying its frame. And of course, since I'm talking about putting it in a super view, that's in the super view's coordinate system, not in the drawing coordinate system on the inside there. Okay? Similarly, center, a lot of people think, oh great, that's the center of my view. But it's not. Okay? That's the center of your view in your super view's coordinate system. So that's positioning you. Okay, frame and center are positioning you. They have nothing to do with your drawing. When you're drawing, you're using your bounds. Okay? So I do not want to see you using frame inside your drawing code or center. Got it? And I'll emphasize this again in the demo. All right. So one thing about frame and center, you might think that the size and width are going to be the same for the frame and center, but they're not, because views can be rotated. And if you had a rotated view, like view B, okay, its bounds is 200 wide by 250 high. You see that? But look at its frame, 320 by 320. Why? Because this is the smallest rectangle in the super view's coordinate system that will completely contain this rotated view. Okay? So the width and height are not the same. Okay? This is the frame, 320 by 320. This is the bounds. When you're drawing in B, you don't even know you're rotated. So you want to make sure that you're using these coordinate system right here. Bounds. Okay? All right. Creating views. Okay, most of the time you're creating views in your storyboard by dragging them out. Now, if you have a custom view that's drawing something custom, like today we're going to do a thing where we draw a face view. It's going to be a view. Okay. Looks like this, got a couple eyes, smiley face, okay? I'm drawing, it's got a skull there. When I'm drawing this, there's no face view in the object palette, right? I can't drag that out into my storyboard. So how do I get my face view to appear somewhere in my storyboard? Well, the answer is I'm going to drag out a generic view, okay, a generic UIView, unsubclassed UIView. And then I'm going to change it, edit it in this identity inspector, which I'll show you in the demo, to change the class of it so it's a subclass of UIView. And it's in that subclass of UIView that I'm going to put all my drawing code, all my face drawing code. Okay? Now, on rare occasion, you will create a view in code. Okay? You do that just by calling UIView's little constructor here. You're going to use the one with frame, not the one with coder. Okay? You can also do UIView with no arguments. That means the tiny little UIView. You'll have to set its frame otherwise. So here's what it looks like to create a view in code. Here I've just created a rectangle, which is 2020, 150. So that's like 2020, 150. So this is this rectangle right about there. And then I'm creating a view. This view happens to be a UI label. UI label is just a subclass of UIView. So it's UI button, so it's UI stack view. All these things are just subclasses of UIView. So I'm creating a subclass of UIView using that frame thing, okay? I'm even setting the labels text, all right? Then I'm going to say view, let's say this code is in a view controller. I'm going to say view, which is that top level thing, add subview, the label, and then all of a sudden it's going to appear here. Okay? Appears at 2020, and it's 100 by 50. Okay? That's it. Very simple to add views with code. Okay? Add subview. All right, custom view. So why do I want to create my own custom view subclass? Obviously, you want to have a smiley face. Okay? So you need to create your own custom one to do that. And you might have some, pinches or swipes or something, which we'll do next week for your face. You need a custom view to do those things. Okay? So let's talk about the drawing end of that today. How do I draw? It's really easy. You're just going to subclass UIView, and you're going to override this one method, drawRect. Okay? DrawRect takes one argument, which is an optimization only, which is what part of the view the system wants you to draw. It might want you to draw the whole thing, but maybe it just wants you to draw the eyes. Okay? Now, you can ignore that and draw the whole thing anyway, and it'll work. Or if you can efficiently just draw the eyes, then you might decide to just draw the eyes. Okay? But this argument right here is purely an optimization. It can be ignored if you want. Okay? Never call this method. If you ever call this method in the code you submit for homework, I'll be personally going over and slap you on the wrist. Okay? Because this is never, ever, under any circumstances, no exceptions, are you calling this thing. The system calls drawRect. Okay? You never call it. So how do you get your face to draw if you want it drawn? Okay? Let's say the eyes close and you want to draw the face so the eyes are closed. Well, you call this method here, setNeedsDisplay, on your view, and that tells the system, hey, this view needs to be redrawn. And the view, at some point in the future, when it's appropriate, will call your drawRect. Okay? Now, why is it done this way? Well, if you think about it, your view lives in an environment where there might be subviews, and you're in a super view, and they're overlapping. There's all kinds of things happening. And you can't just run along and redraw one of those things. Okay? They might be transparent, seeing through to each other. The system has to manage that. Okay? And there's also performance reasons to do it. You might you might close the eyes, start frowning, etc. The nose starts running, I don't know. And all those things are happening all at once. Well, you don't want to redraw every single time one of them changes. You want to wait till all of them have changed and then draw once, your new face. Okay? So the system is the one that decides. Now, this is setNeedsDisplay in rect just lets you set this little rectangle right here. So this is an optimized version of setNeedsDisplay in rect. Maybe you just call it with the eyes, okay, if you know only the eyes have changed. But this is how you get a view to redraw. Okay? All right, so how do I implement this drawRect thing? Okay, I got this drawRect thing. How do I implement it? There's two ways, really. There is a kind of a C-like, a non-object oriented. In Swift, it's just functions, global functions, way of doing it called core graphics. Okay, core graphics. And there's an object-oriented way using a class called UIBezierPath. Okay, they're both using core graphics underneath the covers. So I'm going to talk a little bit about the core graphic concepts, and they're going to apply to UIBezierPath, as you're going to see. So what are the concepts of core graphics? Very simple. First, you're going to get a context to draw in. So that context might be drawing on screen. That's the context you'd want if you're in drawRect. But you could have other contexts like drawing for a printer, drawing into an off-screen buffer. Okay? Those are all contexts to draw, so that's the first thing you do. If you're using this kind of C-like functioned one, you're going to use this UI graphics get current context inside of DrawRect to get the context that's appropriate for DrawRect. Okay? So then number 2 is you create paths. So these paths are made of arcs and lines, rectangles, circles, whatever. You're putting together these paths, this path that you're building, okay? And that's the thing that's going to be drawn, okay? So you build this path. Then you set attributes that you're going to draw this path with, like the color of the lines, any fonts if you're doing text, textures if you're filling things with textures, line widths, line caps, those kind of things. You set all those things up. And then you stroke the path, which means draw a line everywhere the path is, or you fill the path, which means fill in the space contained by the path with some color or texture. Okay, so that's it. This is the basic concept of how you draw. Now, UI Bezier path does all these things the same, okay? It's just that UI Bezier path automatically knows the context to draw in, so you don't have to worry about context. It has methods to draw, like line 2, arc 2, those kind of things, instead of having discrete functions, you know, these global functions. You use UIColor to set the stroke and fill colors. This is a class we'll talk about. And then when it comes to stroking and fill, those are methods on UI Bezier path. So UI Bezier path just kind of encapsulates all that core graphic stuff into a nice class. It's nice because you can find everything you want. Basically everything you want to do to draw except for colors, fonts, text, and images. Those 4 things are not in UI Bezier path, but all other drawing is in there. Okay? So how do you do this? I'm only going to talk about the UI Bezier pathway because it's object-oriented. We love object-oriented programming here. So here's how you would create a path and draw something. So we're going to do a triangle. Okay? So first I create a UI Bezier path. Okay? There are initializers with arguments. We're going to use the one where we just create a blank path. Then we're going to move around. So I'm going to move to 8050, which is like right here. Let's say it's 160 wide and 250 high or something. So 8060 is right about here. Then I'm going to add a line to this point over here, 140, 150. Remember, our origin is up here. Positive numbers are going down. Okay? I'm going to add another line over here, okay, to 10, 150. And then I'm going to close the path. There's a method called close path. And that just goes back to the starting point. So that closes it. And boom, I've created a triangle. Now, I've misled you a little bit here because no drawing on screen would actually happen if you put this in your DrawRect. Okay, if you put these lines of code in your DrawRect, nothing would happen. Because all you've done here is create that path. You have not drawn it on screen. You haven't stroked it or filled it. Okay? So how do we do that? How do we get it onto screen? Well, first of all, we need to set the colors that we're going to use to stroke and fill. So I want my triangle to be red lines with green fill in the middle. So I'm setting green color as my fill color and red color as my stroke color. Notice that I send these to a UIColor. I don't send them to the Bezier path. So it's kind of odd that you do your setting of the colors by sending it to UIColor. So we'll talk about UIColor green color, what that means in a couple of slides. So here I'm setting my stroke and fill, and then here I'm setting the line width of my path to 3 points wide. Okay? Now I can just say path fill, and I get my filled path, see, filled with green. Notice there's no line around the outside. But then if I say path stroke, now I get a line around the side, and you can see it's red, and its line width is 3. Got it? So you're going to have code like this in your DrawRect if you wanted your view to be a view of a triangle. Okay? Any questions about that? All right. Now, you can use UI Bezier path to draw more complicated things like rounded rects and circles and things like that, especially by using a lot of the initializers of UI Bezier path, but there's also methods there. So you're going to have to study UI Bezier path and see what it can do. Okay? It can do quite a lot. Another interesting thing about UI Bezier path is you can set it as a clipping path. So let's say you were drawing a playing card, right? Playing cards have rounded rects. They never have sharp corners, right? They have rounded rects. Well, you could create a UI Bezier path here using this, create a rounded rect, set it as the clipping path, and then just draw your card on the inside, and it would never draw in those corners because it would be clipped to the rounded rect. Okay? So add clip is kind of a cool Bezier path method. The Bezier path can also do hit detection. So you can see whether a point is like inside the triangle, right? If you have that Bezier path that's the triangle, you can do hit detection on it, whether it contains a point. So that's kind of cool too, right? Doing some game or something and people have to touch on a certain kind of funny shaped thing, not a rectangular thing, then it's nice to be able to do hit detection with it. Okay? And there's lots and lots of other stuff. You need to check the documentation. All right, UIColor. We saw that UIColor green color thing on the previous slide. What kind of method is this? You guys remember from last lecture, green color, what kind of method? Type method or instance method? It's a type method, right, because we're not sending it to a UIColor, we're sending it to the type UIColor. UIColor is a class, and so we're sending this method to it. So it would be defined as static or class func green color inside the UIColor class, okay? By the way, you can also create colors, not just picking these well-known colors like green color, but there are initializers for RGB, red, green, blue, HSB, that's hue, saturation, and brightness. You can even create a color that's a pattern, okay? Like some image that you have, it'll make a pattern out of it, and when it draws, it'll be drawing with that pattern. It's kind of cool. Here you see views have background colors. You've already seen that. We set the background colors of our buttons in the calculator. You notice that when we did that in the attributes inspector, we had to scroll down to the bottom because the attribute inspector is object-oriented and it was showing all the inherited things. Well, we had to go down to the UIView level to set the background color of our buttons, okay, because the button inherits that from UIView, okay? Interesting thing about colors, they can have transparency, okay, meaning they kind of show through. That's called alpha. How many people have heard the term alpha when it comes to drawing? Okay, so less than half of you. So alpha just means how transparent it is. And alpha of 0 means fully transparent. So if you had bright red, but it was alpha 0, you wouldn't see any of it because it's fully transparent. You're seeing completely through it with no blocking. Alpha of 1 means fully opaque, meaning you would not see a single pixel of anything behind something that was fully opaque. And between 0 and 1 is various degrees of being able to see through. Okay, that's called alpha. And you can create colors, like here's a yellow, by sending this message color with alpha component. Okay, is this a type method or an instance method? Raise your hand if you think it's a type method. Raise your hand if you think it's an instance method. Hardly anyone raised their hand for either of them. That's great. But the people who raise their hand for instance method, you are correct. Okay, this is an instance method. That's because we use this type method yellow color to get an instance of a color, and then we sent it this instance method to get a half transparent version of yellow. So this is half transparent yellow right here. And if we drew with it, it would draw yellow in our view, but we'd be able to see through to things behind, perhaps even to other views, like our super view behind. If you want to draw with transparency in your view, though, if you want to draw with colors that are transparent, you have to set in your view this var, opaque, to be false. Okay? As a performance optimization, the system has to assume that your view is opaque, okay, that it doesn't draw with transparency. That's because you can imagine things that are transparent overlapping. Think about the work that the system has to do to figure out what's showing through from behind, okay? That kind of compositing, it's called, takes processor power and memory, okay? So it's going to assume that everything is opaque, so it doesn't have to do that. But if you are drawing with transparency, that's fine. Just set this opaque to false to let the system know, no, I'm not opaque. I'm going to draw with transparency. Now, another thing that's cool is you can make your entire view transparent by setting the alpha property on the view itself. Okay? So you can draw your whole view, your triangle, let's say, set the transparency to 0.5, and you'd have a half transparent triangle. Even though you drew all with opaque colors, you'd still have a half transparent triangle because you set your alpha to 0.5. Okay? Using alpha is really cool for doing effects like fading views out. Okay? Sometimes you want a view just to fade out over time. You want to animate that, and alpha is one of the things you can animate. We'll talk about animate in a couple weeks. So alpha is cool for doing that. All right, now let's talk about this view transparency and how that works when you're drawing with transparency. If you have non-opaque views, okay, that say they're drawing with transparency, then what happens is that subviews list that shows all the subviews is in order where the first thing in the subviews list is in the back. Okay? The next thing is in front of that, the next one's in front of that, the next one's in front of that, and so it's going to show through like that. Get it? So the subviews list matters, okay? The subviews list is built by add subview. Everything is always put in the front when you call add subview. But there's another method called insert subview at that lets you put it anywhere you want. You put a subview in the back. Like if you say insert subview at 0, it'll put it up in the back, okay? So just know that that subviews order obviously matters. You can completely hide a view by setting it's hidden to true. If you set it's hidden to true, it will not receive any events, no touch events, nor will it draw what it draws. It'll still be in the view hierarchy, okay, but it's as if it's not there. Now, why would you want this? Well, you might have a view that only appears when a certain button is in a certain state. So you put it there, you set it hidden. When the button goes to that state, you unhide it, and it'll appear. Now, to be frank, you'd probably animate its appearance with alpha, okay? So it would appear like that instead of jumping on screen. That's kind of disconcerting. But you still would probably use hidden to have it hidden in the first place, because you wouldn't want it, for example, getting any touch events or something like that until it was shown, okay? All right, what about drawing text? Okay, we do not draw text with UI Bezier path, okay? Text is really just a bunch of Bezier paths, okay, in a font. A font really defines a bunch of Bezier paths for each character, each glyph, okay, it's called. And so we have higher level ways of drawing text, okay, by basically saying, here's a string, draw it, okay? That's a high level way to get all those Bezier paths to draw. And you don't want to be dealing with that at the UI Bezier path level for sure. But most of the time, we don't draw text even in our draw rect. We draw it by using UI label, which you're used to already. Okay, we just have a rectangle, boom, we put it on here. If we wanted to say hello on this guy's forehead, we might put a UI label right there, say hello, okay? But what if we did want to draw in our draw rect? What if we wanted to put some text in here and we didn't want to put it as a subview, a UI label subview on our face view? The way you do that is with a class called NS attributed string. Okay, NS attributed string, and you create it by this constructor here. Usually you pass a string in here. What an attributed string is, it's a string that for every character has a dictionary of attributes that say how to draw it. And those attributes are things like the color of the character or the glyph, the font to use, obviously, okay, maybe a background color, those kind of things, right? You have a dictionary that has all those settings for every single character. Now, often you have long runs of characters that have exactly the same color and font or whatever, and so you would have one dictionary for all of them. But that is the basic way that attributed string works. And once you have an attributed string, okay, maybe you've set these dictionaries on the characters, then you draw it in your draw rect by saying text, that's the attributed string. You send the method here, draw at point, and then you give it a point, and it's going to draw that text with the upper left corner being at that point. So if I wanted to do that hello, and I drew it right here, the hello would appear like this. Okay, this is the upper left, and it would appear, the text would appear here. Okay, got that? And I could find out how big this is going to be by using this size method, okay, the size property actually, of attributed string. Okay? So that's how we draw text. Now, this is a little bit of a nasty class to use, to be honest, NS attributed string, for a couple of reasons. But all the reasons come from the fact that this is an Objective-C class that really didn't get a very good Swift treatment yet. Okay? So there's two major differences that make using it kind of complicated in Swift. Okay? One is that mutability is not done with var and let. Okay, normally if you wanted an array that you can add things to do, you would just say var x array. And since it's a var, you can add to it. Okay, if you said let x of an array, then you couldn't add to it. Well, that's not true for NS attributed string. You can't say var NS attributed string. That's still immutable. The way you do mutability is with NS mutable attributed string. It's a different class. Okay, so if you want to build an attributed string and start setting the attributes on it, you need to use mutable attributed string instead. Okay? You create it the same way with some string, but now you can set the attributes of it or whatever. So that's one thing that's kind of weird, okay, is this mutable, you have to use this mutable version of it. By the way, NS attributed string is not a string, a Swift string, nor is it an NS string even, Objective-C string. It's its own thing. It does have a property string and another property called mutable string that will give you back a string slash NS string using that bridging thing. But it itself is not a string. You can't pass it as an argument to something that's accepting a string. Okay? NS attributed string is a different thing. Now, the second thing that's difficult with Swift and attribute string is the range here. Okay? You're trying to set attributes. This is how you set attributes in the thing. Here's the dictionary. I'm going to show you what's in that dictionary in a second. And you're trying to set it for a range of characters in the string. You want the font or color to be something for a range of characters. Well, this range is not a range. It's an NS range. Okay? NS range is different than range. And NS range, the index is in here. Okay? It's a struct also that has a start and a range, basically. A distance, start and a distance. But these indexes are into the Objective-C NS string. Now, what's the difference between an Objective-C NS string and a Swift string? Well, as I told you before, a Swift string is full Unicode compliant. Okay? So things like emojis and stuff like that might be multiple characters. So the length of an NS string might be different than the length of a Swift string. Okay? Because Swift string has a lot of possible Unicodes in there, whereas an NS string might not necessarily do the full Unicode treatment. So bottom line, they're different. Now, if you have just normal text, which I hesitate to even say that, because of course you want to build apps that work worldwide. But if you have text where there's no Unicodes in there that are multiple characters long, you don't have emojis in there and stuff, then they're going to be quite similar, these ranges. But otherwise, you might have to be really careful to make sure that you get the range to be the NS string range. That might mean taking the Swift string that you have, converting it to an NS string, which is really easy because it's bridged automatically, and then looking into the NS string to see how long it is and where things are. Okay, I apologize for this. Of course, I have never worked for Apple, so I have nothing to do with it, but this is the way it is. Hopefully, one day soon, Apple will come up with some nice, more Swifty way of doing this. What is in these? By the way, I'm not going to ask you to do this very much in your homework. Okay, so don't worry too much about that. What are the attributes you can put in this dictionary? Well, exactly what you would expect. Okay, the foreground color is the color of the text. Stroke width is how thick you're going to stroke the text. The font attribute name is the font, the UI font. There's a class called UI font. Okay, you put those in a dictionary, and then you can set that for whichever characters you want in your attributed string. Now let's talk about fonts, by the way. Fonts are super important in iOS. Okay, they are critical to the look and feel of it. You can see there's all kinds of different fonts here, right? You see some bold, some not, some kind of like heading fonts. There's system fonts like up here. Look at the use of fonts here, how important that is, okay? So fonts are very important. And if you're going to build a good app, you've really got to pay attention to the fonts. So how do I get the fonts or pick the fonts that I want? Well, there's really three ways to pick it, okay? Number one way is using preferred fonts. So preferred fonts are the fonts you're going to use for the user's content, okay? The stuff the user is actually, like if it's a calendar app, then it's all the things about their appointments and things, okay? If it's the weather app, it's the temperature and things like that. Those are part of the user's content. You get these mostly in Storyboard by going to Attributes Inspector, and you pick the font. And we've only picked a system font, but because we've always just had buttons, which is a system font thing. But for content, you would pick in there preferred font. Okay, and I'm going to talk about what those preferred font styles are in a second. In code, you're going to use this UI font static type function called preferred font for text style and say what kind of text style you want, and it's going to give you a UI font. Okay, so what are these text styles? Okay, there's about 8 or 9 of them, but some examples are headlines, body font, footnote font, and you should use the one that's kind of appropriate to what your UI is doing at that time. Okay, there's like caption font, a couple of other things, all right? And so, you know, sometimes you play with these. The difference between a caption and a footnote can sometimes be subtle, so you might try both and see which one really feels the best. But you're going to use these various preferred fonts to build a cool looking UI, okay, that's beautiful and all that. The second kind of font thing is system fonts, okay, system font of size, bold system font of size, system fonts, what we've been using in our calculator. Those go on system elements like buttons. Okay, that's where you would use a system font. In our display in the calculator, probably shouldn't have used a system font there, because really what's in the display is kind of the user's content. Probably we should have used a preferred font, but I hadn't shown you this slide yet, so I can't introduce it all at once, okay? But that probably would be better. And the kind of font we want to use there might be instead of a, sometimes you want to use a specific font, okay? So the third way here is to use a specific kind of font. Like maybe in the calculator display, we want to use something that looks like LED segments. You know what I'm talking about? The old style funny calculator thing back when we had LED displays. So we might want a font that's LED font, which they make those. In that case, you want to check out UI font and UI font descriptor especially, because those are how you pick a specific font from a specific family, okay, like the LED font family. Okay, so those are the three ways: preferred, system, or highly customized. Okay, how about drawing images? Just like there's UI label for drawing text, there's something called UI image view for drawing images. So you could just put an image. If I wanted to put an image on this guy's forehead, I could just put a UI image here and have my image here. Okay, put it as a sub view of my face view. So that's one way to do it. But if I want to draw a UI image in my draw rect, it's very similar to the text. I'm going to get a UI image. Okay, there's a number of ways I'll show you here to do that, but the main way is you're going to do it by name. You're going to put the image in that images.xc assets. Remember that thing I kept moving out of the way into supporting files? Okay, images.xc assets. So you're going to drag an image in there, give it a name, and then you're going to say image named that name, and you're going to get a UI image. This is optional because this might fail. Okay, you might have forgot to drag that image in there or something, who knows. But once you have this UI image in your hand, oh, by the way, other ways you can do it, you can create it from a file or from just some image data you got from the internet, for example. That's another way to create a UI image. Okay? You can even do it by drawing with core graphics into an off-screen buffer. Once you have that image in your hand here, this var image, you draw it the same way as the text. You say draw at point. That's going to be the upper left. But you also can do draw in rect, which will draw the image but scale it to fit this rect. Okay? Or you can draw it as a pattern, which will tile it. Okay? It'll take that rect and use it as a tile to fill in the rectangle. Okay? So this code would the kind of code that would be in your draw rect. Okay. Last thing here about views, redrawing on bounds change. Okay, when your view's bounds changes, what happens to the face inside here? Okay? So if I had this face and it was in a portrait thing here, let's say it looked like this, okay, face, and I rotated my device and this bounds of my view changed to be like this, landscape, you'd think, oh, well, my face would just redraw and it would probably look about the same. But the answer is not. It would look like this. Okay? It would get stretched out. And that's because the default, when your bounds change, is to scale all the bits, to not redraw. Okay? And that's a performance thing, as you can imagine. It's a lot easier just to stretch those bits out than to ask the draw rect to go again. So you can fix this, though, with this property on UIView called content mode, okay, UI content mode. And some of the values of it can be to move the content to the left or right, top, bottom, top, right, top, left. Okay, you can just move it, not stretch it out, but just move it to that place in the new bounds. You could scale it. This is the default, scale to fill. Okay, that's a stretching out behavior. Or the holy grail, redraw. If you set your content mode to redraw, it'll call your draw rect again. Okay? You often want that. Maybe most of the time you want that. Okay? All right, everybody got that? We'll be doing this in the demo too, so you'll see it. Okay, so I'm not going to come back to the slides, so just tell you what's coming up after the demo. No section on Friday, as we said. Next week, gestures, multiple MVCs, and the view controller lifecycle. Okay, we're going to talk about that next week. And right now I'm going to do a demo where I'm going to do a custom UI view to draw this face thing. Okay? That's the time we're saying I should start the demo. So let's do it. All right, so I'm not going to be doing calculator here. This is going to be a completely new application. All right, so I'm going down here to create new Xcode project. Okay, here it is. It's still an iOS application, though. We'll do single view application. I'm going to call it Face It Okay, it's a face drawing app, so I'm calling it Face It. Make sure it's Swift, not Objective-C, and it'll be a universal app because we're eventually going to do multiple MVCs with this thing too. No core data or testing, okay? We're going to put it at the same place we put the calculator here. No source code control yet. All right, so here's our new app. I'm going to do the same thing I always do with this. I called that images.exe assets, but it's called assets.exe assets. This is where you would drag in your images if you want to do that UI image named foo thing. You'll put them in here. But obviously, I don't need these things as usual, so I'm just going to group them into that supporting file so they're not distracting you every time you take a look over here on the left. Because all we really care about, again, is our storyboard and our view controller. Now again, we're talking about view controller lifecycle next week, so we're going to delete these. All right. Now, the first thing I want to do is actually rename this view controller because it gives me this generic name view controller, which we talked about last week. Not so good. Okay. Well, I don't want that. I want mine to be called FaceView controller because it's going to show a face. So I could just say FaceView controller, and I might think, okay, I'm good to go, FaceView controller. But of course, that's not good enough. First of all, I probably want to rename the file because in Swift, generally the name of the file should be the name of the most important class in the file, okay? Because that's what people are going to expect when they see the name of the file. So that's one thing. But that's not enough either. Because if I go back here to my storyboard and I look at my view controller right here, I can actually look at this inspector up here. If you pick your view controller and look at this one right here, it's called the identity inspector. I can actually see what the storyboard thinks the class of this view controller is. And you can see that it thinks it's view controller. Okay, generic view controller. And of course I renamed it, so that's not what I want. So I can change it though just by clicking here and changing it to face view controller. Okay, so in your assignment 2, it's not a required task, but I strongly recommend that you rename your view controller, because assignment 2 is about the calculator, rename it from view controller to be calculator view controller. You'll definitely want that for assignment 3, but I recommend doing it in assignment 2. Okay, just so this is all you have to do, what I just did. It's not that hard, but it's good practice. Okay, it'll help you understand that the storyboard has classes of things in its identity inspector that have to match up with what's in your code. Okay? All right, so we got that renamed. We want to draw a face, okay? So we need a face view, a UI view, a subclass of UI view that does that. So let's create a subclass of UI view. Anytime we're adding something to our project, we go to File, New, and I'm going to create a new file right here. And this file is going to be iOS source. It's going to be a Cocoa Touch class because it's going to be a subclass of UIView. Anytime we create a subclass of something in Cocoa Touch, like UIView or UIView controller or whatever, this is what we want. So I'm going to double click that. Here it says subclass of. It's already on UIView, but you can create subclasses of NSObject, especially if you're doing Objective-C, or UIView controller, or any of many other classes. But we're going to do UIView here. I'm going to call my view FaceView, okay, because that's what it is, a view that draws a face. Okay, I'm going to put it in the same group right here, this group that has all this stuff in it. Okay, same thing. We'll put it in there. And here it is. Notice that it gave me a draw rect. Look at that, draw rect. But it's commented out. Now, why did it give me a draw rect commented out? And this is because unless your draw rect actually does something, do not have a draw rect. Because if the system sees that you have a UI view that has a draw rect, it's going to think that it needs to get you to draw itself all the time. But if you don't actually draw anything, if maybe you just have subviews, okay, you don't draw anything, then you don't want the system wasting its time trying to get you to draw yourself. Okay? But of course, we are going to draw. So I'm going to uncomment out my draw rect here and start drawing my face. Now, my face is going to look like we drew before here. Okay? It's going to be a rectangle. And here's my bounds, let's say, that I have to draw in. I'm going to draw my face in the middle. Okay? It's going to be the smaller of the width or the height, so the face fits completely, right? And then I'm just going to have a couple of round eyes and a smiley face. And we're going to make it so this smile can be a smile or a frown, or it's movable, basically changeable. Okay? So that's what we're going to build right here. Okay? So since I want this thing to be in the center, and I want it to be the smaller of the width or the height so it fits, I'm going to create two vars to start off for the center and this radius of this thing. So let's do that. Okay, so let's do the radius here. So I'm going to say var. I'm inside my draw rect here. Just implement this. I'm going to call this the skull radius because this is the radius of my face's skull. Okay, I'm going to make that equal to the minimum of the width or the height of my view. Now, what is the width or the height of my view? Now, there's different variables we could look at here. We could look at this rect. Okay, I could say let width equal rect.size.width. Would that be right? No, that would not be right because this rect is just an optimization that says what part of the view to draw. Okay, well, my face needs to kind of draw in the whole view or it won't be the right size. Okay, it would be all small. So this is not the right one. I could say frame.size.width. Would that be right? No or yes? No, I see a couple of shaking heads. No. The answer is no. Okay, frame is the rectangle that contains me in my superview's coordinates. I'm drawing myself. I can't draw in my superview's coordinates. I need to draw in my coordinate system. Okay, so what we want here is bounds. Okay, bounds is the rectangle that I'm drawing in my coordinate system here. Okay, same thing, height, bounds.size.height. Okay, and also I want my skull's radius. I'm not doing the diameter. I want it to be divided by 2. Now it's kind of silly to do these local variables. It's probably a lot better just to take this and copy and paste these right in here like this. Okay, let's make some more room here. All right, so I've got the radius of my skull. That's good. What's the other thing I needed is the center of my skull. So I'm going to call that skull center. Okay, and what is the center? Well, can I say center? Is that good? No. Center is my center in my superview's coordinates. That's where I am, okay, not the center. Now, here's 2 interesting ways to get the actual center of my bounds. Okay, one is, believe it or not, is I can say convert point. This is a UIView method, convert point. Convert center, this point center, from view, my superview. Okay, so I would be converting that point, the center, from my superview's coordinates to my coordinate system. This would be right. This would work because now I'm in my coordinate system. Same point, but it's in my coordinate system. So that's one way we could do it. We probably wouldn't do it that way. Instead, we'd probably use some of the vars that are on CG Rect. For example, I'd probably say something like the skull center is a CG point whose x, okay, x and y of CG point, right? Whose x is probably my bounds mid-x, and my y is my bounds mid-y. Okay, so mid-x is just a property on CG Rect, which tells you the x that's midway across the rectangle. Same thing mid-y. Okay, so I've got my radius and my center. I put these as vars, but really they probably want to be lets, okay, because I've calculated them. I'm not going to change them after this. All right, so now that I have this, I need to create a Bezier path for my skull, for the circle here. So I'm just going to create a local variable here called skull. It's going to be of type UI Bezier path. And so UI Bezier path, and you can see UI Bezier path has a bunch of initializers here. I could use this one oval and rect because a circle is an oval. But I'm going to use this one arc center because I have the radius and center. I don't want to create an oval in my entire bounds. I'd have to create just some kind of rectangle that gets only my skull. So I'm going to use this one arc center, which takes a radius and a center, which I have right here, and then a start angle and an end angle as it goes around the arc, and either clockwise or counterclockwise. Okay, so let's do that. So what is the center of my arc? Skull center. Okay, that's the center of this arc I'm going to draw. This is going to be my skull. The radius is the skull radius. Right, that's the radius I'm going around. Now start angle to end angle, that's in radians. Does everyone know what radians? Raise your hand if you know what radians are. Okay, almost everybody, good. So radians, 0 to 2 pi radians to go all the way around the circle. So I'm going to go from 0 to 2 times pi. Okay, and then I can either go clockwise around or I can go counterclockwise. In this case, I'm going all the way around, so it doesn't matter. So I'll just go counterclockwise, whatever. Okay? So you can see how this is drawn in arc. So I've created a Bezier path, which is, the path is around a circle. Okay? Now, well, I have an error here. What do you think this error right here is? Look at that. cannot convert value of type double to expected argument type CG float. It's pointing to this little thing right here, this M pi. Okay? Well, this is what I was telling you about before. All these drawing things are in CG float. What type is this? What type is that expression? It's a double, right. Okay, so we can't use a double there. It has to be a CG float. So we have to convert it to a CG float by doing this. Okay? CG float. Now, how come this is not complaining? Okay? I told you last time that if you see a literal 0.0, it thinks that's a double. Didn't I tell you that? Well, I lied. Because when it sees 0.0, it can convert it to a number of different types since it's a literal. Okay? Swift can only do this automatic type conversion for literals. Okay? So 0.0 is a literal, so it can convert it to a number of different types. Double, float, CG float, it knows how to do that. Okay? So why does it pick CG float here? Because it knows this method takes a CG float. And when it sees a literal and it sees CG float as the argument type, it tries to convert it to a CG float if it can, which it can. Okay? Everybody got that? All right, so I have this skull. It's of type UI Bezier path. I can set attributes on this skull now, like maybe it's line width. Maybe we'll make it 5.0 points. That's 5.0 points wide, right? If I want to set a color, I don't say skull set color or something like that. I create the color I want. So let's make our skull be blue. Okay, so blue color, which is the type method on UIColor. And I'm going to say set. There's set fill, there's set stroke, and there's also set, which sets both the fill and the stroke. Okay? Now, to get it to draw, I just need to say skull stroke. Okay, and that's going to draw along this arc that I drew with this line width and with the color that's set. Okay, that's all that's necessary to draw the skull of our face here. So now we have this nice UI view, this custom UI view. It draws the skull of a face anyway. How do we get it into our UI? Right? So if we go back to our storyboard over here, right now it's blank. There's nothing in here. There's only this background view. And I promised you that there was a var in this FaceView controller that pointed to this view, and I'm going to show it to you by right-clicking on this. You see it right here? And even when I mouse over it, see how it's highlighting it? This is an outlet called view, just like you have an outlet called display in your calculator. This one is an outlet or a var called view, which is of type UIView, and it's connected to this thing right here. So it's automatically connected up for you. You don't even need to control drag it or anything. Okay, but we're not going to be adding our view in code, so we really don't need that var. I just wanted to show you it was there. I'm going to add my view by dragging it out, and if I go down here to my palette, obviously I'm not going to find FaceView in here. Okay, iOS didn't know about FaceView when it built Xcode, but I can go down to the very bottom here and grab one of these. Okay, this is a generic UI view. Okay, not a subclass of UI view, just a UI view. So I'm going to drag it out and put it here. Now I'm going to do a cool thing. Okay, I'm trying to show you bit by bit a little more of this constraints thing. So I'm going to take this thing and I'm going to use the blue lines. Okay, I'm going to put it all the way up in the corner here, and then I'm going to put the other edge all the way down in the corner down here. And I'm using blue lines. You see blue lines appearing? Those blue lines are making this thing attach to well-known points. In this case, the edges. So I want my face view to fill the entire view. Okay, the entire view controller's view. All right, but just doing the blue lines isn't enough, as we learned. Okay, that's just kind of telling the system what you intend. To make it do it, you actually have to have constraints, like those things we control drag. So I could try and control drag to an edge, control down to this edge, all that, but there's an easier way. If you did all blue lines, okay, and that's all you needed, you can go down here to the same place where you do update frames, and instead do reset to suggested constraints. And that will use the blue lines to put some suggested constraints. Now, let's see what it did. You can see all the constraints on a view by going over to the inspector and going to this tab right here, which is the size inspector. And if you look in the size inspector, down toward the bottom, you can see constraints. You see them? And this is showing me all the constraints. And it put one trailing, that looks good. Leading, yeah. Top, nice. Bottom, perfect. So we put exactly the constraints I want because it followed the blue lines. Okay? So now I have this view constrained to stick to the edges. perfect, because then when I go landscape or portrait, my bounds will constantly be being resized to fit the new shape. Okay? Now, the other thing I need to do is, this is a generic UI view. If I ran right now, it would come up blank because it has no draw rect. Okay? I did that nice face view draw rect, but this is not a face view. So how do I set this to be a face view? Exactly the same way that I set this view controller to be a face view controller. I go to the identity inspector, and instead of so here was when I did the controller, I click on this view, and instead of it being a generic UI view, you see, I change it to be face view. Got it? Okay, so let's run. Okay, it should work. Let's run on iPhone 6, for example. And hopefully, we'll get the skull of our face to draw. All right, perfect. It worked. Okay, so here's our skull. It picked the smaller of the width or the height. The width was smaller, so it picked it. It's drawing the whole size. If I rotate, uh-oh, stretcheroo, okay? So that's this problem where the content mode of our face view is set to be scale to fill. Okay, so it's scaling our thing. So we don't want that. So let's go back here and go to our storyboard and select our face view right here. Go to the attributes inspector. The very first thing is the content mode. And you can see it's scale to fill. And I want it to be redraw. In other words, when my bounds change, call my draw rect. So let's do that. Okay, here we go. Works in landscape, works in portrait. Okay, it's even switching from using the width to the height because it gets smaller, right? Okay, sound good? Now, one of the things that's kind of a bummer, here in my interface builder, I don't see my face. How come I don't see my face in here? And it is possible to make the face appear here, and we'll do that next week, okay? Because it's nice when you're building your storyboard to be able to see your custom views in there. All right, so let's go back to our face view and add some more. Let's add some eyes. How about we'll add some eyes to our face view? And to do that, I'm going to start having some little helper functions here along the way. I'm going to make it so that my eyes and the mouth are all relative to the size of my skull. Whatever my skull size is, I'm going to make everything else relative to it, obviously. So I'm going to take this skull center and radius and take them out of draw rect and make them vars. Okay? These are going to be vars. Now, when I tried to do this, and you'll try this in your homework, I'm sure, you're going to get this error. It says instance member bounds, okay, cannot be used in type face view. And you are going to get so frustrated because you're going to say bounds is definitely an instance member of face view. How come I can't use it here? Okay? And the answer of why you can't use it here is because you are in the initialization phase. You are initializing this. And during initialization, you cannot use your class. It's not initialized yet, so you can't call vars and methods like bounds. Okay? Everyone understand that? So you will see this message, I'm sure. And you will post on Piazza probably and say, what's going on? But I'm telling you right now what's going on. During an initialization, you cannot, until you're fully initialized, you can't access your own properties. So what are we going to do here about this? Well, I'm just going to change this to be calculated, okay, to be a computed property, okay? I'm going to just return this value right here, okay? Now, two things about computed properties. Notice that I didn't say get open curly brace, close curly brace. If you have a computed property that only gets, you do not need to put the get in there, okay? And we never would. It looks much nicer not to put it. Same thing here. This is a CG point. We're going to return this. Okay? Not going to put the get in there. All right? That make sense? Now, one other thing I want to do is my skull is all the way out to the edge. I'd like my skull to be able to be kind of scalable, to be smaller than the edge. So I'm going to add a public var called scale. Okay, which is going to be a CG float, and it's going to scale my skull. And I'm just going to do that by here when I'm calculating the radius, I'm just going to multiply it by my scale. And I'm going to set it to 90% so that my skull is kind of 90% of all the way in. Now I'm going to use these two vars, okay, these computed vars, in all my other calculation, eyes and mouth, all these things, I'm going to use the same thing. So we'll do eyes today, and then mouth. We'll either do mouth at the start of next lecture, or maybe I'll just post. I'm going to post this code, by the way, on Piazza afterwards. Maybe I'll just post the mouth code so you can take a look at it. But let's do these eyes first. How do we do the eyes? To do the eyes, I need kind of the ratio between the skull radius and the eye size. So to make things quick, I'm going to type those in real fast. Here they are. Okay, so here's all the ratios from the skull's radius to the eye's offset, to the eye's radius, to the mouth's width, height, and offset, etc. Notice how we do constants in Swift. We create structs, and then we have type variables, static, type variables, okay, which are lets. They're typed like this too, that has the value, okay? So this is how we do it. Notice these are capitalized, and of course this is the name of a type. We always capitalize the names of types. Don't forget that, okay? Some of you don't like to do that. Please do it. In Swift, we capitalize all type names. And we also capitalize these, okay? These static things that are basically constants in this struct. And I'll show you, we're going to access these by saying ratios dot this, okay? Because this is the name of the type. This is the value in it. So I'll show you that when we start using these. So how am I going to do this? How am I going to make my eye here? I'm going to create a new method here. First of all, let me create a little type here, which is an enum. I'm going to call it eye. It's going to have left eye and right eye. That's just so I can talk about my eyes in my API. And then I'm going to have a func, which I'm going to call path for circle centered at point. Okay? It's going to take a midpoint, which is a CG point, and I'm going to have with radius, which is going to be a CG float, and it's going to return a UI Bezier path. So this is going to be a utility function. Okay, it's private actually. Let's make sure we get this private, and this is private also. Okay, these two are absolutely private. I'm going to try and get in the habit of actually putting my privates in here so that we get our things proper. This is properly public, okay? So this function is just going to take a center point and a radius and give us a Bezier path, exactly the same thing we're doing here. So I'm actually even just going to copy this, cut it actually, and put it here. Okay, so we got that. And the center is not the skull center, it's the midpoint. And the radius is not the skull radius, it's this with radius. Now, this kind of points out this weirdness of having something that reads nice when you call it, because when I call this down here, I'm going to say path for circle with centered at point, the skull's center, with radius, the skull's radius. That reads really nicely like English. Okay, got this nice preposition in here. But when I'm inside my code, it's kind of weird that this is called my with radius. Okay, that doesn't really make sense. I really want this to be called radius inside. So this is where I'm going to have the internal name and the external name that we talked about. See that? Okay. So that's all that this is going to do. I'm not going to return it directly, though. I'm going to let the path equal this, and then I'm going to use this to set my line width as well. In fact, let's just cut and paste this as well up here. So I'm going to have all my line widths to be the same. Okay, this is probably something I want to make a var out of, just like I have the scale. Probably want the line width also to be settable, but for speed, we'll keep going here. And then we're going to return that path. Okay, got that? Make sense? By the way, when we have a really long line right here that wraps, one way that we can kind of make it look nicer is just put every argument on its own line. Like that. Okay, it's just a little more readable that way when it's really long. So I've got this right here, and I've replaced this skull thing with this. Okay. By the way, I don't really use skull except for to do this stroke. So let's take this, cut it out of here, and put it here. Okay. Everyone see what I did there? I'm just chaining, calling this, and then calling stroke on it. And it's pretty obvious this is my skull because I got skull center, skull radius. Okay, so now I have this path for circle. I can use that to draw my eyes as well. So I'm going to have another private func here called get eye, what did I call it? Oh, path for eye. Path for eye. and it's going to take an eye, which is of type I, and it's going to return a UI Bezier path. Okay, so this is going to get an eye, either the left eye or the right eye, depending on what this argument right here is right here. And to do that, I need the eye radius. So we'll have the eye radius, which is going to be equal to the skull's radius divided by one of these ratios up here. Okay, in fact, this ratio right here. So we'll say ratios dot, this one is skull to eye radius. Okay, and then I'm going to let the eye center equal the, I'm going to actually call a function here, get eye center for the given eye. Okay, and so let's do that. Private func get eye center for a given eye. And that's going to return a CG point, which is going to be the center. All right, so how do I get the eye center here? That's pretty straightforward here. I'm just going to say, what did I decide to do here on that one? Yeah, so I'm going to let the eye offset equal the skull radius divided by ratios for the skull radius to the eye offset. Okay, so I'm just, see how I'm just doing all the positioning of everything based on the skull radius and the skull center. So then I'm going to let the eye's center equal the skull center. So we'll start with the eye being right in the middle of our face. Then I'm going to move it up and over. Right? So first of all, let's move it up by saying that the eye center dot y minus equals, because y minus is up, plus is down for the y axis, the y offset. So I'm going to move it up by the y offset. And then depending on which eye it is, okay, if it's the left eye, I'm going to move the eye offset dot x to the left, okay, minus, oops, this is eye center. Actually, this should be eye center also. We're going to move the eye center to the left by the eye offset. And if it's the right eye, then I'm going to move the eye to the right by the eye offset. Okay, so that tells where our eye is. So I'm going to return the eye center here. Okay, everyone got that? Where the eye is? So we have warning here. What is it? Let var. Okay, so this needs to be var, or no, this needs to be a var, I guess. This needs to be a let. Okay, get a lets and vars, right? Yes. Okay. So here we're going to get the center of the eye using that function. So we have the radius and the center for the eye. So now we can just return a path for a circle centered at point. The eye center with radius, the eye's radius. Okay, so we have this path for eye. Now we just need to stroke this path. So we're going to say path for eye. For eye, let's do the left eye and stroke that. And then path for eye, let's do the right eye and stroke that. Okay, notice by the way, I can say dot left here. I don't have to say eye dot left, because Swiss can infer that path for eye, it's going to be an eye. Okay, everybody got that? Make sense? So hopefully now when we draw, we'll get some eyes on our face. Oh, didn't quite work. Okay, so let's close. What happened there? We got an eye. The left eye looks good, but the right eye is kind of stuck in the center. So why is that? Let's look here. Well, it looks to me like I moved the, for right eye, I moved the center Y back to the, where it was before. See, I moved there. So this really needs to be the X. See that? So I'll run that. Okay, bingo. Got face. Can rotate them. It's looking good. So now we need the mouth. Okay, let's see if we have time for the mouth. Yeah, we might. Okay, we'll get started on the mouth anyway. So here I'm going to do the same thing, private func, path for mouth this time. Okay, there's only one mouth. And it's going to return UI Bezier path. Okay, and then we're going to do the same thing down here. We're going to say path for mouth, stroke. Okay, so how are we going to do the mouth? I'm going to have to use a Bezier curve to do the mouth. How many people know what a Bezier curve is? Raise your hand if you know. Almost nobody. Okay, so a Bezier curve is just a line you draw between 2 points, but you have 2 control points somewhere where it tries to draw a tangent line to the control point and start the curve on there, and then it draws a tangent line to the other control point and tries to draw another one there, so you can make curves. okay, using these little control points. So I have to determine the start and end and the 2 control points. So first I'm going to create a rectangle to contain my mouth here. I need these mouth ratios. So the mouth width and height and offset I'm going to make as ratios to the skull radius. Okay, save a little time by doing that. And then I'm going to make the mouth rect. Okay, the rectangle that contains the mouth by saying let mouth rect equal a CG rect. And this CG rect, I'm going to use the x, y, width, height initializer here. So the x is just the skull center dot x minus the mouth width divided by 2. Okay, so my mouth is going to be whatever the mouth width is from the skull center. Move it over. And the y is similarly going to be the skull center dot y plus, actually, the mouth offset, because we're going to put the mouth down below the center of the face, so we're going to do it down. The width is just the mouth width, and the height is the mouth height. Okay? And just to show you what this is like, I'm going to create a rectangle. UI Bezier path has a constructor which is creates a rectangle using mouth rect. Okay, so let's run that. Let's return that, actually. Okay, that's the path we're going to use. We're just going to do a rectangle at first. I'm not going to do those control point things yet. So our rect is going to be a rectangle. So this is where we're going to do the mouth. If it's smiling, it'll be down here. If it's frowning, the mouth is going to be up here. Okay, so we're going to put this here. And this is going to be the start point of my Bezier path. This is going to be the end point. I'm going to put 1 control point here and 1 control point here for a full smile. And so it's going to start heading down towards this control point, bottom out, and then start heading towards the tangent line between here and this one. So that's what's going to make a smile. Okay, don't worry about it too much if you don't know Bezier path. So here I'm going to type this in really fast just to save some time here. Most important thing is this mouth curvature. This is just a double, which is somewhere between -1, which is a full frown, and 1, which is a full smile. Okay? And so the smile offset, first I'm going to make sure it's between 1 and -1. Okay, that's all I'm doing here. But the offset is going to be that 1 to -1 times the mouth's height. That's why I'm going to put my control points always down at the bottom if the smile is 1. Okay, that makes sense? All right, so here I'm going to start at the mouth's upper left. I'm going to end at the mouth upper right. Okay, my first control point is 1/3 of the way along the bottom, and the second control is 1/3 of the way from the other side. Okay, and on the bottom, wherever the smile offset puts it. Okay, so in a full smile, this is going to be along the bottom of the rect. It could be up above the rect. Okay, so I got that. So now I'm just going to return a UI Bezier path here that incorporates all that. Let's actually do this. Let's say let UI Bezier path, path equal UI Bezier path. I'm just going to create a blank one. Then I'm going to tell the path to move to the start, move to our starting point, which is start. That's this thing right here. Okay, then I'm going to create a Bezier path from there, a Bezier curve, which is add curve to point. That's the way you add a Bezier curve to a path. It goes to the end point, which is this right here. And here's my 2 control points, CP1 and CP2. Okay, that's these 2 guys. All right, so I've done that. I'm going to set the line width equal to 5.0 and return the path. Okay, so let's see if that works. We have our mouth here set to be 0, which is not a smile or a frown. It should be just kind of straight line, because our control points are going to be right along the line. Sure enough, this is not a very happy camper. Let's make them very sad. Okay, oh, that looks very sad. But I don't want to send you guys out of here sad, so we're going to go to full happy here. There it is, very happy. Okay, now one thing I'm going to do, last thing I'm going to do before we leave is this mouth curvature is currently a local variable inside this private method. I'm actually going to make this public. Okay, so I'm just going to take it out of here, put it, I like to put my public vars up here at the front, with scale. Put it there, I'm going to make it a var, okay, that's public. So now other people using my FaceView can set how happy it is, right, because I've made this public. So they can set whether it's a smile or a frown. Okay? And that's going to be really valuable next week when we start having multiple MVCs, because we're going to want to be able to use other MVCs to show things. Okay? So just to show this still works, the mouth curvature is still a full smile. There we go. Okay, we'll pick this up next week.
For more, please visit us at stanford.edu.